Hello everyone, a very good evening. So lately I have been uh, practicing some problem solving and programming questions to improve myself, and I thought I could share whatever I'm learning with you guys. So today we'll be discussing and trying to code out this solution for this question, where you have been given two strings and you have to check whether they're anagrams of each other or not. So the definition is that the two strings are said to be anagrams of one another if you can turn the first string into second by rearranging its letters. So in short, what it means that if two strings are having exactly the same letters, but they can be arranged differently, then they can be called as anagrams of each other. So let's see with an example. So for example, this is the word one, which is apple, Apple. And let me take this. And this is Aeplp. Okay. So we have A here, we have E in both, we have P in both, we have again P in both, and we have L in both. So these two words are anagram of each other. Okay. They have the same letters, but just arranged differently. So they are the anagrams. Okay, let's see these letters W1 and W3. Now, here if you observe one thing, the unique number of unique letters here is A, P, L, and E. Okay, and here as well, the unique letters are A, P, oh, I can write, okay, let it be L and E. So although they both have the same unique letter, they're still not anagrams because the count of letters is different. So here A is 1, P is twice, L is once, E is once. Here A is once, but P is just once. And here P is twice. So in order for the two words to be anagram, they need to have not only have the same unique characters or letters, but also the count of those unique letters or characters need to be same. So in our case, W1 and W3, they are not an anagram because the count of any specific letter here, P or E, is not the same. And comparing W1 and W4, you can see that this has a K and this does not have K. So they too are anyhow not an anagram. So this is the concept of what anagram is. And now we have to see how we can, solve it. Algorithmically. Okay, fine. So now from the definition of the problem itself, we know that we have to check for two things. One is that same letters. So we have to ensure that, oops, we have the same letters in both the words. Okay, same letters or characters. And another is that the count of each letters need to be same. Okay, now if it was only same letter, checking whether there's same unique character in both of the words, then we could have used, sets like a data structure, and you could have just seen that if word one, if all the words in if all the characters in word one are present in sets, and then check for the word characters in word two, are they present in sets, and we could have done with it. But we also have to maintain a count. So here one most obvious data structure that comes in mind is using some hash table, and in Python, it's the dictionary. Okay, so how can we solve it? So what we'll do, let's take the first word, which is apple, Apple, and we'll create a hash table out of it. Now our hash table will contain two things, whether this is the character and the count. Okay, these are our key values. So we will loop over it. We'll check A. If A is, we'll check whether A is present in this table. So A is not present in this table. So we'll simply put A and we'll put as count as 1. Then we check P. Is P present in this? No. So we'll insert P as a key and its value would be 1. Then we again see P. Is P there? Yes, P is already there. So we need not create a new key. What we'll do, we'll increment the count of P from the previous one. So simply add 1. So this becomes 2. Then we check for L. L is not here. And we make count 1. And then we check for E. So yeah, and sorry. E is not there, so we'll make count of 1. Now, what we can do for the second word, let's say second word is the W2, which is E, sorry, AEPLP. Okay, so let's first create a new hash table for it. Actually, we can do it, solve this with just one of the hash table which we have. But for now, let me create, two of them just to get our intuition clear. So we have again the character. So this was for the word one, and this is for the word two, and these are the counts. Okay. Now we again loop over it. So we'll say and one thing that you can check to terminate early is whether the characters that you are now observing, are they present in the word one dictionary. If not, imagine that there was a K here, and you take K and you see K is present here or not. And if K is not present, then you simply terminate it. You do not proceed further because it won't be anagram. For anagram, we need to have same letters and the same count. So we could do a check if A is present here. Yes, it's present here, so it's we can consider it. And then we again, sorry, I took a eraser here. So again, what we do, we start filling our dictionary with key as A, and the value as 1. Then we check E. Is E here? Yes, E is here, so it's a valid character. And we put in the key and we increment it. Then we check for P. Yes, P is there. We put 1. And then L. Yes, L is here, so we can insert in this table. Then we check P. Is P there? Yes, so plus 1 equal to 2. Now what we can do, we can simply then loop over any of the table, like say W1, and we take the key, say A, and we check the count is 1, and then for the same key we check the count here. If both are same, the count of this is equal to this, we say okay, this is fine. And then for the P, we check count is 2. Again, for the key P, the count is 2, it's fine. Then for the L, we check both the count are 1 1, it's same. Then for the E, same. So in this way, you will, by comparing, you will know that okay, the characters are same and the count is same, so these two are anagram. Now here I use one more hash table. So actually we don't need this, we can eliminate this. So let's see how we. So let me create some space here. Okay, so let me make this a table for word one once again. So I have this hash table of character and count, and I have A as 1, P was 2, uh, L was 1, and E was 1. Sorry, I'm new to this. I'm really struggling. Okay, so now what we can do, when we take the second word, for example, A, E, P, L, P. So when we are looping, say we are on this character A. So first of all, we'll check whether A is present in this or not. So if it is present, then well and good, we move ahead. If not, we terminate the entire searching program because it will not be an anagram. So we'll see A is there, and then what we'll do, we have count 1. We will simply subtract 1 because we have seen one similar character. So let's make it one less that we have seen, and it becomes 0. So this is gone. Now we come over here, E. We see E is present here or not? Okay, E is present. So we subtract 1. So it become -1, it becomes 0. Then we come to P. We'll check P is there. Yes. Then we'll simply subtract 1 because right now we are just observing one character. So -1, it will be say 1. Then we come to L. Is L present here? Yes. Then we simply subtract -1. This becomes 0. And then we come to P and we check, is P there? Yes. So we subtract -1. It becomes 0. So basically you have to check that at the end, all have to be 0 because then only the number of count of each letter is going to be the same. So what we can do is when you are looping over, say you take the uh, character A, okay? Before subtracting, you can check whether the count is 0 or not already. So what I'm trying to say, for example, let's assume that this word has, one more character as A. This was 6 letter word. So you'll take A and you see whether A is there or not. A is there. Now you check whether the count of A is 0 already or not. If the count of A is 0 and you still have an extra A at your hand, which you're observing, it means that this is an extra A. Because had it been equal number of A, then it would have, not have been 0 yet. So this extra, because of this extra A, this is not an anagram. So you can do just two check. So first check is to check whether the character is in the word one dictionary. Okay. And the second check you have to do is whether the count of that character is already if it's already equal to 0 and you have a character, it means you have to, it's not an anagram. We have an extra character. So it will get make more sense when we code it out. So we'll simply break it. But if the count is not equal to 0, you know, it means there are some characters left here, then we simply subtract it, subtract the count minus equal to 1. And at the end, with these flags and you keep on looping, you will be able to find, whether this is anagram or not. Okay, we'll code it out, and yeah, it will make more sense. Now let's observe the what is the time complexity and the space complexity of this problem. So if you see the time complexity, we are looping twice. So one over the word one. So this could be worst case of O of n, plus we are looping over the second. So plus O of n. So this sums to our, O of 2n, which is simply O of n. And the space complexity, so we are using a hash table. So here we are not using 2, just 1. So space would be simply O of n. Okay, this is your so this is one of the solution. There is another solution which is like this is the more efficient one. That is a different one which we'll discuss in the next video. So this is it. Yeah, and one more thing that I wanted to say here, one more check that we can do at the beginning itself is to check the length of the two letters. So if the both letters are anagram, then the length of both the letters need to be same. If length is not same, so this is 5 and this is 5, then only they can be anagram. If there was one extra letter, say A, then this becomes 6. So anyway, there's no chance this could be anagram. So this is one check we can put at the beginning. Okay, so now let's code out, then it will make more sense. So I have these two words. So let me just write a function, say define check anagrams, and I will be getting input as word 1 and word 2. And as I said, the oops, the first check that we can do is simply check the length of both the words, because the anagram says that this exact same letters need to be there and it can be arranged differently. So if length of word one, sorry, not equal to, then simply return false, say. Okay. And if that's not the case, then we move ahead. We'll create, the dictionary for word one, and let's name it character count dictionary, and we'll loop over all the character in the word one. So for character in word one, and what we'll do, we'll check if this character is in this dictionary. If it is in the dictionary, then we need not create a new key. Simply we can increase the count of the existing character. So it will become plus equal to 1. However, if it's not the case, that this is not in the dictionary, then we have to create a new key in the dictionary with that character and assign a value of 1 to it. So with this, you'll be able to create your, this character count dictionary table. So let me run and show you this. So these were the two words, and let's see if our dictionary is getting created as intended. Okay, so now you can see, okay, here we can see, I can print it here as well. character count, and you will see we have a dictionary, a hash table, with key being the letters and the values being the count of each of the letters. So we are okay now, we have created it. Now what we'll do, we'll take the second word. So for character in word 2, and one of the check we have to do beginning is if character is not present in the dictionary. So oh sorry, dictionary name is character count. If it's not present, it means it's not anagram. We have a different letters, so simply break out, return false, whatever. And another check is if the character is there, but if the value of that character, say value of that character is equal to 0 already, it means we have an extra letter in the word too, then also we return false. Okay, and if that's not the case, then what we do is simply subtract the value of that specific key or the character by 1. So we'll make it okay, and at the end, if everything goes well, then we can return true. Cool. Now let's call this function with our word check anagrams, word 1 and word 2, and we can print to just see the result, what is being. So let me run it. So you see it's true. They are the anagram. Now let's try some other words, or the word 1 being say apple, and this one being say we will try a single P and double L and E, and let's see if what we get here. So it says it's false, so it's not an anagram. So similarly, you can try out multiple different characters, and yeah, so apple and say mango something, and if you run it, okay, we get a false. So you got the idea of how this code works, and the as we discussed, the time complexity of O of n, because of this two looping over the word 1 and word 2, and space is O of n because of this dictionary. And this is yeah, this is one solution. There is a one more solution, but it's more costlier. We can do it by sorting and then checking it. So we'll discuss in the next video. So for this video, I think you got the I think we discussed how to solve this. So this is one way. Maybe there are even much more efficient which I'm not aware of. So if you want to share, you can share in the comment. So thank you for being with me, and I hope you learned something. Until then, keep safe and keep learning. Bye.